Okay, students, we want to focus in on capital budgeting, specifically the internal rate of return. So go to your Blackboard, find your PowerPoints for internal rate of return. Okay. Also, you need to go to your tables. We mentioned those before, so find your tables. And what you need is your annuity table. So let me pull that up. Okay. Your annuity table, this is what it looks like. I believe this is table 4 and 5. And we specifically want A5 on your tables. We'll be using these columns, A5. Okay. Now, let's take a look and do a quick review on the PowerPoints. Internal rate of return. What are we talking about here? Okay, I want to back up and let's look at, let me get rid of your tables here because I don't need this. I've got a hard copy and this is your Blackboard. So find that information right there. And let me pull up the PowerPoints again. And I want to talk about briefly again what is internal rate of return and what is capital budgeting. Capital budgeting is again the idea that you're going to be purchasing either a large piece of equipment, property, plant, deciding on a project or a major investment in stocks, bonds, something like that. You have to make a decision, and these are methods to do that. We've already looked at accounting or average rate of return. We've looked at cash payback. We've looked at net present value. Now internal rate of return. Remember the time value of money. $1 worth more tomorrow because you can invest it. Okay. And present value concepts, there's a single sum, there's also an annuity here. Okay, annuity is what we're focusing in on, which is a series of payments that are equal. So going to your problem, this is the problem that's on your handout. We're going to get $10,000, or we expect to, a year. That's an annuity for 5 years. We desire a return or a percentage of 12%. We're paying $33,530 for the equipment. So is this a good investment, and what is the lowest return we would want to get? Okay. Now, internal rate of return actually means what is the lowest acceptable percentage you want to earn. And it's also the place where the net present value is 0. So you could do this 2 ways. The first is a trial and error method, which is rather complicated. But what you would do here is you would start with the 12%. You would find your table, find your factor. 12% at 5 years is the factor I've circled, 3.60478. You would multiply that times your 10,000. If you do that, you're going to get $36.50. You want to subtract out the cost of your machine, $33,530. That gives you a net present value of $2,520. Okay. Now, we want to find that percentage, not 12%, but what percent is going to give us a 0 net present value, and that's the lowest return we would accept on this project. So it's a trial and error method. You want to move up because the higher the percentage, the lower this net present value. So for instance, you would move up to 13%. You would do the calculation at 13%, see what you get. And I don't have those computations. You can do it. I think, let's see, 10,000 times 3.517 would give you like 35,000. and that would lower your net present value to around $2,000. If you go up to 14%, 10,000 times 3.43 is going to give you about $34,330, and so then your net present value ends up being around $1,000. We actually don't go any higher than that on our table, so we're at a limitation. We're going to have to accept the fact that this problem, the number you're looking for, is around 15%. So if we had one more column, we could calculate this, and we would come up with 10,000 at 3.353. Okay, again, if you look at your table, it only goes to 14. So what you're talking about is 5 years at 15%. This number would be 3.353, this number right here. When you multiply it times 10,000 and subtract your cost, you come up with exactly a zero net present value. So in this particular problem, your internal rate of return is 15%. Okay, 15% is your internal rate of return. And that's the lowest, okay, you would want to go. So in this case, you would not want to have any kind of project where the rate, this rate, is above the 15%. So to accept, okay, the desired rate of return must be less than or equal to the internal rate of return. So 12% has to be less than or equal to 15%. You would not want this number to be 16, okay, because then you wouldn't accept the project if the net present value is below zero. Now, a much easier way to do this, to find this number, is to do a calculation that involves a formula here. Amount to be invested divided by your equal annual net cash flows. Equal annual net cash flows. In this case, what, 10,000? Okay, and this would give you a rate of 3.353, and then you go to your table at 5 years. Okay, so let's go to our table over here. You would go all the way across and you'd look for these rates, and obviously it's not here, but it would be under the 15% column. So once you found that rate, you would go up and you would be able to see what your percentage would be. Okay, let's work another problem with this. Okay, here's another problem on our page. Assume management's considering the proposal to acquire equipment costing $97,360, and the equal annual net cash flow is $20,000. So $97,360 divided by 20,000, that's your formula. When you run that through your calculator, you get 4.868. Now, what you do is you go to your annuity table, you find 7 years. Okay, so let's come over here. Let's find 7 years. You want to go all the way across until you find that factor. Notice there it is. And then you go up, and this would tell you that your internal rate of return is 10%. Okay, your internal rate of return there is 10%. So you would accept anything below that. Okay, minimum accepted. You want to make sure this is the rate where the net present value is 0. Okay. Now let's take a look at Vantages. Cash flows, time value of money, it ranks your proposals. Okay, if you get the internal rate of return, you can look at what the different companies have as far as a return, and you want to pick the one that's the highest, whatever's going to give you the highest number there. Complex, it assumes cash can be reinvested. That's disadvantage here. Okay. Now, go through and work these two problems, or is it just one? This problem, and get the internal rate of return on this problem, and we will take a look at those later. Thanks.